Can you hear me okay?
Yes.
Yeah, the QR code takes you to my group's page that we're terrible at updating. So just get in touch if you want to follow up afterwards. Right, so I'm going to say three things. That ICT is growing fast and having environmentally significant impacts on energy systems and various other things. That when we design solutions with digital technology now, we're locking in dependencies for the future, which I ardently believe. And that we need to be thinking much more systemically for the long term about designing systemic solutions, not doing things in silos, really. So the Anthropocene, I'm sure this is a term you already know, is the era where humankind is the dominant factor in shaping the Earth systems. And I would argue, we've spanned the globe with digital systems, and most solutions in any other domain involve digital parts. So these are sort of intertwined anyway. And a few years ago now, and needs updating really, with colleagues at Small World, we wanted to get a sense for how big is ICT in terms of global emissions. So we looked at the sort of published accounts of this. We then followed up with interviews from the authors, Anders Andre, Jens Modim, and Lofty Belkier, and then using the experience of Small World with tech companies, we wrote this report. And we looked at the sort of narratives that are in the literature, sort of justifying ICT's footprint as well. And we think that ICT then, which was sort of 2018 to 2020 data, was already equivalent to global air travel, and the differences in accounts are generally scoping decisions about what you include, what you think of as ICT. Do you include smart TVs, IoT devices or not? And the sort of truncation error in life cycle analysis. And also it sort of assumes some future growth trends of various things. And I think since then we've seen a massive resurgence in AI, for example, and various other things. So it's globally big. I guess about half of it is embodied in the small devices that are in their billions, but the rest is sort of infrastructure and back end really. So one of the narratives you see often is that IT is getting more efficient, Moore's law, just replace the kit with more kit, and that will solve the problem. But our opinion of this is that this just takes you to, it lowers the cost of doing something. You get what's known as a rebound effect. You've probably heard this before. And the sort of original citation for this, if you like, comes from William Stanley Jevons, who was looking at coal use in the Industrial Revolution, and this diagram comes from his book, I think. And it basically shows that as the amount of coal you need to generate a certain amount of energy goes down, so the overall demand goes up because it becomes more attractive to have more steam engines. And I think this is where we are with a lot of digital technologies as well. Another argument that's often made, for example, in Jesse 2030 and to some extent the Twin Transition document, is that ICT decarbonizes other sectors by sort of dematerializing things and delivering things digitally and video conferencing. But the backdrop for this, I would say, comes from this show your stripes picture, which is showing you parts per million of CO2 in the atmosphere. And then the color represents the warming effect. So it's getting warmer. And even the UN are saying we're not on track, and so I don't think I buy that. And another point I'd like to make really is that if we're going to get down to relative emissions back to a baseline level, it's not that all actions are equal out into the future. It's that if we take action sooner, less GHG, greenhouse gases, end up in the atmosphere. And they hang around for a long time. So there's quite a lot of lag in the system. So acting sooner is better, acting faster is better, and trying to avoid tipping points where there are sort of runaway effects, and things become sort of accelerate further is desirable. So it's important not to think about this as the marginal cost being the same out into the future. Right. So we should be trying to reduce demand. So with that in mind, if we're caring about, say, Sustainability Development Goal 7, which is about energy and equal and reliable access to energy, digital technologies, especially things like data centers, are drawing considerably on energy systems and our substantial energy users. And what we've seen, I'm just going to pick on AI because we're into a second. The diagram on the right here is the sort of two generations of AI, and we're into this generation where the y-axis is petaflops. This is number of computations to sort of train and inference models. And we're into this new generation of large language models, deep learning, LLMs, where there's an arms race to essentially use more and more energy to produce bigger and bigger, more effective models. And nothing's really having a braking effect as long as they can afford to do this. And the question I would just like to ask is should we be just letting this run away without limit, or is this going to steal energy from other things? So sort of headline numbers, inferencing ChatGPT was about 7 metric tons of CO2 a day in February 2023. It's a lot bigger since. The Google search, which has just decided to embed AI into the summarizing the responses of every search, is 10 times more energy intensive than it was before. Generative AI workloads are going up at a compound annual growth rate of 39%, and this is driving growth in data centers. So these rates are much faster than things like Moore's law. And that each AI rack with its GPUs and NPUs and accelerators for AI is a lot more energy and materials intensive. So even a paper that came out of Meta in 22 was talking about how their carbon footprint was in fact shifting from sort of direct energy, where they were decarbonizing their energy systems, to the supply chain, because as the models get bigger, they cease to fit on the existing hardware, or you need more hardware, or you need to rent more hardware. And when it sort of exceeds the onboard memory capacity of the graphics cards, you need to buy more graphics cards, which is sort of good for NVIDIA, I guess, but is leading to sort of bigger and bigger data centers. And I was chatting to an energy provider in the northwest of the UK, and they were saying they used to be asked for under 10 megawatts, and now they're being asked for 100 megawatts to supply these kind of data centers. If we care about sustainable consumption and production, SDG 12, then there's also implications on the supply chains. So the demand for the rare earth materials that are making all these sort of CPUs and GPUs is growing at a growth rate of about 10% a year, which is faster than other materials demands are growing. And that's just a nice picture by Dylan Marsh of a visualization of the environmental consequences of digging a quantity of copper out of the ground, which is, obviously we could have a view on extractivism, but I won't go on about that. But another point that I think needs making is that the same elements, these are the elements of the periodic table, and the ones in orange are on the critical minerals lists as being in short supply. We're using a lot of rare earth and heavy elements now, more with each generation really, and 45 critical elements are needed also for energy storage and harvesting renewables. And there's a sort of strong overlap between ICT and the energy system materials. So we need to be thinking about the two together. I guess a final point on wastefulness. The Global E-Waste Initiative says that only 22% of e-waste is officially recycled. The rest finds its way, and there's obviously some extremely exploitative practice around how e-waste is handled, and sort of between global north and global south, there's inequity. And also, I suppose one of the things is that some of these rare earth materials exist in tiny quantities within these ICT devices, so they're incredibly challenging to recover just by the sheer scale of what's required. Essentially a large chunk of those rare earths are just ending up lost to us for the future. So I think sort of accelerating the materials demands is going to become more and more of a problem. So I suppose one point is that when we want to decarbonize our energy system, we need to decarbonize our energy system, then it also takes energy, materials, time, planning, and changes the landscape to do new forms of generation, whether it's solar panels, wind turbines, storage systems, pump storage, whatever it is. And there are limits to that, and the limits to how much land we can afford to dedicate to that, because we might want to do some other things like food crops, biodiversity, housing, and various other things. So things that can grow very fast, I would say, are a threat to electricity grids because they're taking away energy supply for other things, and there's the significant scale of investment in digital technology gives them a sort of powerful lever to displace other things. So I suppose I'd make this point that there may be things we could do with digital technology that we actually can't afford to do, and need to be thinking about regulation and limits and various other things. So here's a little example. So this is from Sweden, in the Malmö region, where a Swedish bread company, Pergen, I apologize for the pronunciation, couldn't build a bread baking factory in the area because so much electricity had been booked from the energy supplier by tech companies. So it's sort of this idea that digital can displace other things, and there are various sort of reasons data centers get located where they are, but they often cluster together, and you can see in the US this is already having a big impact in some regions because of tech companies are taking on supplier agreements and reawakening nuclear power stations and all sorts of other energy systems level things. So we're starting to see pressure on energy systems. This is not a particularly good diagram, but this tries to illustrate the planned renewable energy supply and the planned consumption and the roadmap for renewables in various countries to hit net zero. We're already seeing in places like Ireland that the expansion in data centers is sort of taking over 50% of their renewable capacity in 2022, and is looked to take more than its share, I guess I would say, of their renewable potential. So I suppose I'm probably going to be a bit quick here. I didn't really expect to be so quick. So this is the Ponte Vecchio, I think, in Florence, and I like this picture because it basically shows a bridge with where people have built on the bridge and live on the bridge. And I suppose the point I'm making here is that when we build infrastructures, they enable other things, and then once you've built that infrastructure, it changes the future, and you build other things on that infrastructure and you rely on it. And I think as we build digital tools, we need to be thinking systemically about what is that infrastructure we're building out. So I'll sort of finish up really. I don't think we need to be greening the world today. We need to be planning much more systemically for a sustainable, resilient tomorrow. I think it's the case that by digitizing things, it won't reduce energy demand on its own without a more systemic approach. And it could introduce new dependencies on energy and materials that we're not fully embracing yet. If the energy demand per capita goes up, then this is going to be in conflict with other things we need that energy for, like heating and transport and other really huge electrification challenges and global supply chains and so on. And it's going to be in that mix. And if digital wins, then it displaces other things. If it could well disruption to energy systems, more volatile energy systems could well disrupt digital systems. So we need to be thinking of a more resilient digital world as well when we design for a changing climate. And I guess my main point there is that we need to be transforming to a lower demand and more resilient infrastructure designed for long-term sustainability. So I've found this sort of Slovenian eco house just to sort of illustrate not necessarily a a regressive attitude to technology, but a need to think about simple, resilient systems. So I'll just leave you with some points. Digital applications have significant environmental, material, social costs. I've talked less about the social costs. Kate may well pick up on that in a moment. I think ICT is growing at an exponential rate, especially in things like AI and blockchain. And I haven't talked about IoT at all, and could be wasting precious renewable energy and materials that we need for a sustainable future. And I think we need to think systemically now about how to reduce demand and the future pathways that we're embedding, a bit like our bridge. And that's all I plan to say. Sorry, I've finished a bit early.